Hello students. So today we'll be looking at the evaluation of DFT, that how do we evaluate DFT. This method will be used only to evaluate a 2-point or at the most 4-point DFT. So let's say a discrete input signal x of n is equal to 1, 2, 3, 4. And the DFT is given by x of k is equal to summation from n is equal to 0 to 3, that is n minus 1, x of n into e raised to minus j 2 pi k n by capital N. Here this k is the index of frequency and this small n is the index of time. What do I mean by index? Let us say x of 0, that is in time domain the first sample at x of 0 is 1. Then x of 1, when I substitute small n is equal to 1, it will be x of 1, that is the second sample in time domain sequence, which is equal to, whose value is equal to 2, and so on. Likewise, k is the index of the signal in frequency domain, that is x of k. Right. So there are 4 samples in time domain sequence and there will be 4 samples in frequency domain signal, that is x of k, and the summation is with respect to n. So there are 2 variables here in our case, k and n. One is the frequency domain index variable, which is discrete, and also a time domain variable which is also discrete in nature. Clear? In all other transforms that we have learnt up till now, just had one variable. So it was the one dimensional transform, but this will become a 2-dimensional transform since there are 2 variables in it. So let us start. Let us say for k is equal to 0. So for k is equal to 0, x of 0 is equal to summation n is equal to 0 to 3. Sorry. So x of 0 is equal to summation from n is equal to 0 to 3 x of n into e raised to minus j 2 pi, k is 0. We have substituted, we are considering k as 0 for the first calculation. So k 0 into n by n. So what will happen? This whole term will become 0. So it will be e raised to 0. What is e raised to 0? That is equal to 1. So value of this whole term will be equal to 1. So what were we left with? We are left with only summation n is equal to 0 to 3 by x of n. So now go on substituting. Now let us open up this summation. So first for n is equal to 0, it will be x of 0, then plus, increment the value of n. So now it will be x of 1, then plus, increment again the value of n. So now it will be x of 2 plus x of 3. What is x of 0? Here is x of 0, that is 1. What is x of 1? It is equal to 2 plus 3 plus 4. So the first sample of a frequency domain signal is 10. Clear? Now let us consider k is equal to 1. So for k is equal to 1, it will be x of 1 is equal to summation from n is equal to 0 to 3 x of n into e raised to minus j 2 pi k is equal to 1 into n upon n. Now n in our case is equal to 4. I will directly mention here 4. So 2 pi by 4 will give me pi by 2. So I will just n is equal to 0 to 3 x of n into e raised to minus j pi by 2n. Okay. So now the variable is n. K ka value we have already substituted it as 1. So now we have to open up the summation which is with respect to n. So x of 0 के लिए x of 0 into here n will be equal to 0. For the first value of n is 0, so n will be equal to 0. So e raised to 0 is equal to 1. So into 1. I am directly writing the value, I am not substituting the value of n. Then plus next value of n to be substituted is n is equal to 1. So x of 1 into e raised to minus j pi by 2 plus next value of n is 2. So e raised to minus j pi by 2 into 2 and plus x of 3 into e raised to minus j 3 pi by 2. Okay. So we will continue here. So x of 1 is equal to x of 0 plus x of 1. Now here we can say x of 1 is multiplied by e raised to minus j pi by 2. E raised to j pi by 2 will be cos pi by 2 minus j sin pi by 2. If we are aware of the identity, e raised to j theta is equal to cos theta plus j sin theta, right. So e raised to j pi by 2 will be equal to cos pi by 2 plus j sin pi by 2. Similarly, for e raised to minus j sin pi by e raised to minus j pi by 2 will be cos pi by 2 minus j sin pi by 2. What is cos pi by 2? It is 0. Sin pi by 2 it is 1. So e raised to minus j pi by 2 will be equal to minus j. Do not worry, by the end of DFT all of these things will be on your fingertips. So x of 1 into e raised to minus j pi by 2. So again, what is e raised to minus j pi by 2? It is equal to minus j. So x of 1 into minus j. Now the next term is x of 2 into e raised to minus j pi by 2. So basically it is e raised to minus j pi. Now again, what is e raised to minus j pi? It is cos pi minus j sin pi. Alright. So if I say e raised to minus j pi is equal to cos pi minus j sin pi. Alright. So what is cos pi? Cos pi is equal to minus 1 and sin pi is equal to 0. So what is e raised to minus j pi? It is equal to minus 1. So can I write here, instead of plus x of 2 into e raised to minus j pi, can I write here minus x of 2, right, because this term is equal to minus 1, okay. So it becomes minus 2, and then the last term is x of 3 into e raised to minus j 3 pi by 2. So again e raised to minus j 3 pi by 2 is equal to cos 3 pi by 2 minus j sin 3 pi by 2. Cos 3 pi by 2 is 0 and sin 3 pi by 2 is minus 1. So minus j into minus 1 will give me plus j. So what is e raised to minus j 3 pi by 2? It is equal to plus j. E raised to minus j 3 pi by 2 is equal to plus j. So I can write here plus x of 3 into j. So now let us substitute the values of x of 0, x of 1, x of 2 and x of 3. What will we have? 1 minus 2j minus 3 plus 4j, okay. So the final answer would be minus 2 plus 2j, that is just x of 1 is equal to minus 2 plus 2j. Now similarly we can do it for x of 2 as well, that is when we substitute k is equal to 2. So if I substitute k is equal to 2, it will be summation from n is equal to 0 to 3 x of n into e raised to minus j 2 pi k n by n, where capital N is equal to 4 since we are taking 4-point DFT, and small k will be is equal to 2. So basically what do we have here is, it will become e raised to minus j pi n, okay. So now go on substituting again, open up the summation. So it will be x of 0, n is here 0, so which will get multiplied by 1, plus x of 1 into e raised to minus j pi plus x of 2 into e raised to 1 2 minus j 2 pi plus x of 3 into e raised to minus j 3 pi, okay. So x of 0 into 1 plus, what is e raised to minus j pi? It is cos pi minus j sin pi. Cos pi ka value is minus 1, sin pi ka value is 0. So here we will have x of 1 into minus 1. So here I will replace this plus by a minus sign. Then we have x of 2 into e raised to minus j 2 pi. Again, what is e raised to minus j 2 pi? Is equal to cos 2 pi minus j sin 2 pi. Cos 2 pi ka value is 1, sin 2 pi ka value is 0. So it is equal to 1. So x of 1 into 1, sorry, x of 2 into 1, and again x of 3 into e raised to minus j 3 pi. Now again this is an odd multiple of pi. For odd multiple of pi, odd integer multiple of pi, the value will be minus 1, and for even integer multiple of pi, the value will be plus 1, right. So that is why minus pi ke liye it is minus 1, sorry, e raised to j pi, whether it is plus pi, plus j pi or minus j pi, the value will be minus 1, and here for e raised to either plus j 3 pi or minus j 3 pi, the value again will be minus 1. Similarly, for e raised to plus j 2 pi or e raised to minus j 2 pi, the value will be always plus 1. That is, for odd multiples of pi, the value will be minus 1, and for even multiples of pi, the value will be plus 1. So here again I will have e raised x of 3. So let us substitute these values. So it is 1 minus 2 plus 3 minus 4. So the value is minus 2. Clear? That is x of 2. And similarly, when you substitute or k ka value as 3, you will have the value minus 2 j. Try this last one on your own, substituting the value of k is equal to 3, the last one on your own. So this is how you evaluate a 4-point DFT. Too lengthy process, right? So we will try to simplify this by something called as by making use of a twiddle factor. We learn about the twiddle factor in our next lecture. Till then, kindly please try to solve this whole problem on your own. So if I want to write my final answer, it has to be written properly as x of k is equal to 10 comma minus 2 plus 2j comma minus 2 comma minus 2 minus 2j. Clear? This is my final answer.